Okay, so the last thing that we're going to discuss in this section is the power of the test. All right, so what exactly is the power of a test? So how good of a test you have, the power of the test, and the probability of a type 2 error are related. So basically, the power of the test is the ability to reject the null when we need to. Okay, so let's just take a minute and think about how the power of a test and the probability of a type 2 error are related. Now, remember the type 2 error is failing to reject the null when it's false. The power of the test is the probability or the ability to reject the null when it is false, okay? So type 2 is failing to reject it when it's false, and a power of a test is rejecting it when it actually is false. So if you think about that, they're actually complements of each other. So the power of a test against a specific alternative is the probability that the test will reject the null at a chosen significance level when the alternative value is true. So the power is basically the ability to reject the null when the alternative is actually true. So basically the ability to reject the null when you need to. Now we said, how are the probability of a type 2 error and the power of a test related? Well, remember, a type 2 error is failing to reject the null when it's false. A power of a test is rejecting the null when it is actually false. So they're actually complements of each other. So in order to get the power of a test, you do 1 minus the probability of a type 2 error, or 1 minus the power of beta, because we're saying the power plus the probability of a type 2 error is 100%. You're either rejecting or failing to reject the null. Okay, if you think about that, because type 2 error is failing to reject, the power is rejecting it, those two together equals 100% of the time, or the area under the curve. Now just keep in mind that you won't ever have to actually calculate the type 2 error, but you will be given beta, and you can calculate the power by doing 1 minus beta, or 1 minus the probability of a type 2 error. The significance level of a test is the probability of reaching the wrong conclusion when the null hypothesis is true. Okay, so this is actually talking about the type 1 error. All right, so remember, a type 1 error is the null is true, but we actually reject it, so we're reaching the wrong conclusion when the null hypothesis is true. The power of a test is the ability to detect a specific alternative and the probability of reaching the right conclusion when the alternative is true. So it's the ability to come to the conclusion that the alternative is true when in fact it is actually true. We can just as easily describe the test by giving the probability of making a type 2 error, or by beta. Okay, and when I say describe the test, it's basically like talking about the ability to reject the null when we need to. So how powerful is it to find evidence against the null? All right, this is basically just saying that the power of a test is 1 minus beta, or 1 minus the probability of a type 2 error. Okay, so let's just take a look at an example. So the potato chip manufacturer potato chip producer wonders whether the significance test of 0.08 versus greater than 0.08 based on a random sample of 500 potatoes has enough power to detect a shipment, say with 11% of blemished potatoes. So basically, I want to reject the null when I need to. When I actually have 11% of blemished potatoes, what is the probability that I'm actually going to reject the null so that I don't produce potato chips that have a lot of blemishes in it? So in this case, our particular type 2 error is to fail to reject. Okay, so remember, a type 2 error is failing to reject the null when it's false. So what we're going to take a look at is what happens. So what if P is actually equal to 0.11, or what if the proportion of blemished potato chips is actually 11%? So earlier we decided to reject the null at the alpha equals 0.05 level if our sample proportion yielded or if our sample yielded a sample proportion to the right of the green line. So basically, if the probability of our statistic occurring was 5% or less. Okay. Since we reject the null at the 5% level, if our sample proportion, or if our sample yields a proportion greater than 0.0999, we'd correctly reject the shipment about 75% of the time. All right, now you would actually be given that number, or you'd either be given the power of the test or you'd be given the beta. You wouldn't have to come up with that on your own. So what if the proportion is actually 11%? So If the null is false, remember a decision to fail to reject is based on the data is a type 2 error. So if the null is false, we fail to reject it. Okay, the null is false, but we actually keep it. That's your type 2 error. So this right here is the power of the test to detect that P is actually 0.11 when it actually is. So that's like saying 75% of the time I'm actually going to reject the null or reject the fact that my potatoes have an 8% blemish rate when in fact they actually do have a blemish rate greater than 8%. Okay, and like I said, you will never have to come up with this, just to understand what it actually means. All right, and right here, this P is 0.099. That's not the probability, that's the sample proportion. Okay, just to clarify that. Okay, so what I'd like you to do is just take a look at this applet, and I just want you to see what affects the power of a test, because there's different things that affect the power of the test. You want to have a test, obviously, that's powerful, that is able to reject the null when we need to. This is going back to our basketball player problem, back from a couple of previous slides ago. The question is asking you, how can we increase the power of the test to detect that the player is actually exaggerating? If he doesn't actually shoot 80% of the time, how much evidence do we need to prove that? So what I'd like you to do is just go ahead and take a look at these questions on the applet and see how you do, and see if you can figure out what exactly affects the power of the test. Okay, so go ahead and just take a look at questions 2, 3, and 4. And then hopefully this will help you understand the connection between the probability of a type 2 error and the power of the test. Okay, so now that you've done that, let's just take a look at what exactly are the 4 factors that affect the power of the test, and why does this matter, and what can you do to make sure that you have the ability to reject the null when you need to. All right, sample size. So when you increase the sample size, it makes the sampling distribution more narrow, right? Remember, it decreases the standard deviation, so it decreases the spread. So there's going to be less overlap between the distributions of the null and their alternative. All right, so basically what that means is the null has a distribution based on a center at, say, 0.08, and the alternative has a distribution based on a center at 0.11. We're trying to find which one's actually true. All right, if there's not very much overlap, then it's easier to reject the null when we need to. The trade-off is it's often difficult and costly to increase the sample size. All right, now what about the significance level? If you increase alpha, it actually makes it easier to reject the null, which actually increases the power because we're rejecting the null more often. Okay, so it's allowing us to reject the null more often when we need to. The trade-off, though, remember what that is that then increases the probability of a type 1 error because we are rejecting the null sometimes when we shouldn't. Okay, so that means just make sure, just take that into consideration, which one is worse, a type 1 error or a type 2 error. The effect size. So what this means is if the true value of the parameter is farther away from the hypothesized value, it will be easier to detect the difference and reject the null. So that's basically just saying if you have a statistic that's far away from what the null is, or what you think the population proportion or mean is, then that's going to give us a much larger ability to reject the null when we need to because it's far away. Okay, and then there's other sources of variability. If we can collect data in a better way, it's going to be easier to see a difference. Okay. In many cases, studies won't be funded unless they can prove that their study is going to have sufficient power. No one wants to pay for a study that only has a 10% chance of detecting a real difference. So when you look at the power of a test, if it has like a 90% chance of detecting a difference when there is, then you want to say, hey, that's a pretty good test. Let's go for it. All right, so go ahead and take a look at this question. You work at a retail store. The alarm on the store frequently sounds when people are leaving. You must decide whether to check someone's bag for stolen merchandise when they leave or just let them go. So what I'd like you to do is, given this situation, state the null and alternative hypothesis in words. Okay, so the null is that the person has stolen merchandise. The alternative is that they have not stolen merchandise. All right, what is the type 1 error in context of the situation? So remember, we're going to actually put it in context. Don't just say the null is true but we reject it. Okay, so remember, type 1 error is getting rid of the null, but it is in fact true. So in context of the problems, we've gotten rid of the null. We're assuming that they have not stolen merchandise and we let them go, and they get out of the store with their free merchandise. What's a type 2 error in the problem? We're failing to reject the null when it's false. Basically, we're keeping the null, but it's not true. So we're keeping the null. The person has stolen merchandise, but in fact, we assume that they have stolen merchandise when in fact they haven't stolen anything. So you check their bag and they didn't steal anything. Describe the power in context of the problem. So actually that's just saying basically interpret, because you don't have a number for the power. So it's the probability of not checking a person when they have not stolen merchandise. So the ability to reject the null, so rejecting it is not stolen merchandise, is the probability of not checking a person when they haven't stolen it. Okay, in order to gain power in your test, be sure to make wise choices when you're collecting your data. You can increase the power by, if you're creating an experiment, this is an experiment instead of just taking a sample, we can block an experiment, we can use stratified random sampling, that's going to decrease variability, and we can maximize power is to choose a high as alpha level as possibility that you're willing to risk. Okay, so thinking about what the type 1 error would be, is it bad or not too bad? Try to choose a large as sample size as you can possibly afford. And we are finally done with this really long 8